Hello. In this video, I'm going to explain problem 6 from the 2015 F equals MA contest. In this problem, we have 3 trolley carts moving on a one-dimensional frictionless horizontal track. We're given the initial velocities of all 3 carts and their masses, and we're told that collisions between carts A and B are perfectly elastic, and collisions between carts and B and C are perfectly inelastic. And we're told to find the velocity of the center of mass of the system, of the whole system of the 3 carts after the last collision. So the key is that the velocity of the center of mass is just equal to the total momentum divided by the total mass. Now, by the conservation of momentum, each collision will conserve momentum, and so the total momentum is conserved. Also, the masses of the carts don't change, so M total is conserved. And so this is a constant throughout. And so when they tell us to calculate the velocity of the center of mass after the last collision, we can just calculate it before the first collision, which is meaning that we can just calculate VCM here, and it'll be exactly the same. And this kind of makes sense because these numbers, 1.9, 1.1, 1.3, 1.7, 2.5, they seem very unwieldy, and so it seems relatively unlikely, just based on those numbers, that they would actually make you do very many collision calculations. And sure enough, we don't. So what is the total moment? So the total mass is just 1.9 kilograms plus 1.1 kilogram plus 1.3 kilograms. That's 4.3 kilograms. And the total momentum in kilogram meters per second, it'll be 1.9 times 1.7, and that is 3.23. And then minus 1.1 times 2.5, so I'll get minus 2.75, and this is all in kilogram meters per second, and so that will be 0.48 kilogram meters per second. And so the velocity to the center of mass is just 0.48 kilogram meters per second divided by 4.3 kilograms. And so that will be roughly, so 48 divided by 43 is 1 point. You can just do that in your calculator or just approximate close enough to get one of the options. But 48 over 43 is 1.1163 roughly, and so here would be 0.1163 meters per second, and so the answer will be option A right here, 0.11 meters per second. And that's all there is to this problem. Alright, thank you for watching, and I hope that was helpful.